Hello. I wanted to talk a bit about password encryption. We're getting to the point where you're likely to start, your own project soon, and you're likely to have a user base. And you might use something like Auth0 or Google Identity in order to keep track of authentication and passwords and stuff, so that way you don't have to store them. But you can do that on your own. And I just wanted to talk a bit about that because, there is the potential of data leaks. Somebody could throw the dictionary or whatever at your password in Mongo and maybe crack your password and gain access to your database. And if you had a collection that was like called user auth or something like that, an example of a you know object in that database looked like this. It was like had some underscore ID of whatever, and then it had email, and it's like, okay, I'm Bimmy at whatever g.c gmail.com, whatever. And then if you had a key called password, and whatever. If somebody gained access to this whole database, and maybe you've got thousands of people, whatever. Well, now they have a one-to-one relationship between people's email addresses and a password that they have used. And not everybody uses auto-generated passwords, which would make this kind of stuff useless. Some people reuse passwords, and if someone unfortunately used the same password for your service that they used for their email address, this bad player now has access to their email, which is like the gateway to a lot of security in your life. Somebody could really wreak havoc on you. So that would be pretty bad. So what we want to do, instead of storing your passwords like this, we want to store an encrypted version of the password. And an encrypted version of the password is basically useless to someone. Because you can't retrieve the original password from an encrypted password. All you can do is verify if something you have is that password. Which means if somebody has an encrypted password, for them to get the original password, they basically have to just start guessing every string under the sun to try to figure it out. So let's see how to do that. We're going to use something called bcrypt. It's an npm package, right? Scroll down a bit. It means we're going to have to yarn add bcrypt. Here we're doing with npm. So let's do that. Let's start by doing our yarn init. And I'll just enter my way through this. Perfect. Now I have a package JSON. Cool. It's yarn add our bcrypt. Shouldn't take too long. I can delete this. Oh, there's nothing here. Cool. All right. So now we have bcrypt in our dependencies, which means we could require it. Let's go and look at the usage description for bcrypt. All right. We're going to need, well, the main thing we're going to really need is bcrypt. There we go. Nice. Love it when they one-to-one relate them. I mean, of course, you could name it whatever you want. It's a default export. All right. So what we're talking about when we're talking about encryption is hashing. A hashed password is an encrypted password. Here they give us two different ways of doing it. In one case, we are generating a salt. A salt is kind of like a randomized initial value for the later encryption. Without salting an encryption, it would be a lot easier to hack, essentially, because it would always start at the same value. So this just further makes it difficult to crack. But we don't have to actually do this extra pattern of generating our own salt. If you hash without doing the salt originally, you can just pass a number to the hashing method, and it'll do it for us. So let's grab this snippet of code here, put it over here. So this is what it looks like. You might recognize this kind of pattern. We showed you earlier on during the promises lecture, in one of the earlier lectures, how to make the node version of a promise handling, and that was like this. You'd have a callback function, and the first thing would be the error, and then the second one would be the resolve. So I don't really like this notation because I'm not used to it. Let's build a function, constant. Let's say hash a password. All right. We should probably make this an async function. All right, and what it's going to do is it's going to accept a password, so like an incoming password, and it's going to execute this stuff. So let's constant hashed password is equal to, and it's going to be this stuff here. Yeah, so in this case, it wouldn't be my plain text password, it'd be the incoming password. And here, salt rounds is just going to be a number 10, and we're going to have to make sure we await this value. All right. So now we have an asynchronous function that hashes a password. I mean, realistically, you'd have to return the hashed password. For now, I'm also just going to console log it so we can test it out. Let's console log that hashed password. Hashed a password? Is that what I called it? No. Oh, that's the name of the function itself. Right. All right. So we're going to console log that hashed password. So now we could conceivably, call this function. We could pass it one password, pass1, and let's call it again and pass it a different password called hash2. All right. Let's execute this file and see how it works. Boop. All right. So here are our two hashed passwords. They both start with a few of the same characters, but then they quickly diverge massively. And this is just from one digit being different. So, good luck to someone or even an algorithm looking at this and trying to revert back to this. So that's how you'll hide a password. Now, just because you can hide a password, that's great, but you can't actually use it unless you can have an incoming password to test against it, right? Because the whole point of saving in a database this hashed password would be that if someone tries to log in, they're going to submit their password. You need to be able to see if the password they submitted matches the saved password, right? So bcrypt has you covered there too. To check a password, we can use the compare. So over here we have a compare method. I'm going to do this in here. So let's say bcrypt.compare. Again, I'm going to avoid this kind of notation, and instead I'm just going to await it. So let's say constant test1 is equal to bcrypt.compare. Oh, we should definitely await because this is a promise. Anytime you see that function notation thing, right, it's a promise, so we'll have to await it. Or you could use .then notation too, but it would, end up having a bunch of, nested .thens and catches and stuff. All right, so here we have our incoming password, and we get our hashed password from it. So let's compare the incoming password to the hashed password. Boop. All right, so let's console log out our test1. So if I run this, true, right? Okay, so that's good. So if we use the compare method and we pass the same password that we, just saved, or hashed rather, this compare method eventually, because it's a promise, returns true, which is good. So we can validate that it is the same password. Let's just go one step further and make sure that we can get a fail case, when we pass it something that isn't the password. Otherwise, because if it's always true, that's no good. So let's, some gibberish, could be anything. True, false. Cool. Don't be confused about the ordering here, because these are promises. If I just do one, because they're promises, it's not synchronous code, so it's not necessarily the case that we'll get this one, then this one for this, pass 1, and then pass 2 will run and it'll do this and this. It's not the case. These are being executed virtually at the same time, and so it's a race. Whichever happens first happens first. So if I do it first, true, false. So we have a true for the comparison of the original and a false for something else, right? Which is good. Obviously it'll work the same for pass 2. Very nice. Okay, so we're in a position now where We understand the functionality of bcrypt. I mean, we don't understand it under the hood specifically, but we can leverage this for how to, save information, and we can begin building a server with this. So I'll pause this recording here, and we'll move on to the next one where I use a server with endpoints to hash passwords.